So in this session here, I get to look at examination past paper questions on topics like rate, ratio, proportions, scale, and percentages. So let's get started with this. Helen won 42 million in a lottery. She shared the money with her parents in a ratio of 5:2, respectively. Find how much money she gave her parents. Now, I'm going to make, I'll be doing 10 numbers of these in this session, 10 numbers on these topics of rate, ratio, scales, and proportions. So, okay, now here we go. So, Helen won 42 million. That's how much she won in a lottery. She shared the money with her parents in a ratio of 5:2, respectively. So, meaning that this was her, Helen. Helen shares the money with her parents in a ratio of 5:2. Okay, respectively. So they're asking find how much money she gave her parents. So this is the money she shared. So what is the total ratio? So let's identify here the total ratio. The total ratio here is 7. So it means it is this total ratio that is corresponding to the 42 million that she shared out between her and her parents. So the question says that find how much money she gave her parents. So with her parents, she gave her money that is in proportion to a ratio of 2. So in other words, so this is going to become 2. That is the proportion that she gave to her parents out of the total ratio, which is 7. Multiply that by the total amount of money she won, which so happens to be 42 million. So we shall say it's 42 million. Then by 7 once, by 7, this is 6 million. So 6 million, multiply that by 2, that gives you 12 million. So that's how much money she shared with her parents. Well, that's how much money she gave her parents. Moving on to the next number. If m is directly proportional to the square of n, and n is 2 when m is 1, find the value of m when n is negative 5. This is a number on proportion. So if m is directly proportional to, so it's directly proportional to the square of n, to n squared. Alright, so that's what the question says. If m is directly proportional to the square of n and n is equal to 2, so meaning that when n is equal to 2, the m is equal to 1. That's what the question says, that and n is equal to 2 when m is 1. So when n is 2, m is 1. So they want us to find the value of m. So what's the value of m when the value of n is negative 5? Alright, so we have an expression here, first of all, that m is directly proportional to n squared. So what we are going to do is that we are going to remove this proportionality sign here and introduce an equal sign. So this is going to become m is going to be equal to n squared. But for us to remove this proportionality sign, it comes with what we call a constant of proportionality. Let's call it k. It could be any other letter. So we are going to first have to find that value of k. So since we have two values that we know, when m is 1, n is 2, then we can use those to find the value of k. So we shall go ahead and say when m is 1, that is going to be equal to the value of k times n squared. N squared is 2, that is 2 squared. So from there we can go ahead and say that this is 4k, and so we know here that our value of k is 1 over 4. Now that we have found that our value of k is a quarter, so now we know that this equation here, this one here, the relation is now that m is going to be equal to a quarter n squared. Now this is the expression. Now that we now know the equation the equation that relates m to n, now we can go ahead and find the value of m when n is negative 5. So we can simply come here and say that m is equal to 1 quarter n squared. So we want the value of m So m is going to be equal to a quarter times n. We want m when n is -5. So this is -5 squared. So this is going to become, of course, -5 squared is going to give us 25/4. And so our final answer here for the value of m is going to be 6.25. Moving on to the next. Two quantities y and x are related by the equation y is equal to a plus bx, while y is equal to 4, x is equal to 2, and when y is equal to 6, x is equal to 4, find the values of a and b. So here we have an expression that is in the form of a straight line. Two quantities y and x. They are related by y is equal to a plus bx, something like that. So they're saying that when y is 4, so when y is 4, x is equal to 2. So when y is 4, x is equal to 2, let's formulate that equation. This means that y is 4 is going to be equal to a plus bx. Our value of x here is 2, so it's going to plus 2b. That is equation 1. Then also the same question continues to tell us that when y is equal to 6, so here when y is equal to 6, the question says x is equal to 4. The value of x is equal to 4. So we shall go ahead and substitute that in that expression above, this expression right here of y is equal to a plus bx. So again, we shall go ahead and say that y, when y is 6, so meaning when y is equal to 6, is equal to the value of a, which we do not know, plus the value of x is 4. So this is plus 4b. That is the second equation. And so now they're asking us to find the values of a and b. So from this you realize that we have formulated two simultaneous equations for a the equations are 4 is equal to a plus 2b, then also 6 is equal to a plus 4b. Now there are very many ways of solving simultaneous equations, but since this one let's use elimination. But if you use substitution method, you should still be able to get the same answer. So now here, let's use elimination, and we are going to eliminate a. So it is this equation minus that equation. So when we subtract those two equations, 4 minus 6 is going to give us -2. It's going to be equal to a minus a, which is 0. Then 2b minus 4b is minus 2b. From here, we can see that -2 is giving us -2b. Divide both sides by -2, and we shall end up with our value of b as 1, because this is cancelled with that, by these ones, by these ones. So our value of b there is 1. After finding our value of b as 1, we can go ahead and find our value of a. So we can just pick on any of these equations. Let me pick the first one, which says that 4 is equal to a plus 2b, then meaning that 4 is going to be equal to a plus 2 times b. Now we got our value of b as 1, so that means it's going to become 4 is equal to a plus 2, and from here our value of a is 4 minus 2, which is 2, which is equal to a is 2. So our value of b is 1 and our value of a is 2. These are quite free marks, quite straightforward numbers. Moving on to the next. 3 girls, Auma, Asimwe, and Nakato shared 10,500. Nakato got twice as much as Asimwe, and Asimwe got twice as much as Auma. Find how much money Asimwe got. Again, let's summarize this. We have Auma, we have Asimwe, we have Nakato. They shared 10,500. That's more like the total they shared. So Nakato got twice as much as Asimwe. So meaning if Asimwe got X, Nakato got twice as much as Asimwe. That's what it means, that Nakato got twice as much as Asimwe. So if Asimwe has X, then Nakato got twice as much as that. Then they are saying, and Asimwe got twice as much as Auma. And then Asimwe got twice as much as Auma. So meaning that if Asimwe got twice as much as Auma, it means that for Auma it's going to be X divided by 2, because Asimwe got twice as much as Auma. Find how much money Asimwe got. So let's add up those three, because when we add this, we should be able to get the total amount of money they shared. And from there, we shall be able to get the value of X, and that is what Asimwe got. So let's move like that. So this is going to become X minus 2, that's over 2, that's what Auma got, plus X plus 2X is giving us 10,500. So from here, we can find the LCM here. LCM is 2 divide by 2 is 1, 1 times X is X, plus 2 divided by 1 is 2, 2 times 2 is plus 2X, plus 2 divided by 1 is 2, 2 times 2 is plus 4x, is going to give us. So moving on, this becomes, multiply both 2 on both sides. This goes with that, we shall remain with 7x, giving us. So of course from here, we shall go ahead and find the value of x by 7 once by 7, that is 3,000. So we have 3,000. So 3,000 means that is how much Asimwe got, because the question asks here that find how much money Asimwe got. So since the value of X is what Asimwe got, so Asimwe got 3,000, and that's the answer. If an area of 4 centimeters squared on the map represents an area of 576 kilometers on the land, find the representative fraction of the map. So of course, a representative fraction is something that it's just simply a ratio that shows, it's a ratio of a specific unit on the map to a unit on the actual ground. For example, representative fractions, which are mostly denoted by RF, you can find that it's going to be 1, maybe 1 to 10,000. This figure of 1 to 10,000 simply means that 1 unit on the map represents 10,000 units on the actual ground. So when they give us this information here, you're seeing they are asking us to convert this information into that kind of form, a representative fraction. So let's read the question again. It says that if an area of 4 centimeters squared, so we are actually talking about area. This is an area on the map that is 4 centimeters squared. It is representing an area of 576, and this is in kilometers squared on the land. This is on the land, this is on the map. So they want us to find the representative fraction. So we shall begin by saying that 4 centimeters squared is representing 576 kilometers squared. Now take note that here we are looking at area, okay? We are looking at area, so we need to remove that square so that it becomes linear, because this representative fraction, this is linear. So to remove that square, it means that we are going to square root both sides. So what's the square root of 4? That is 2. So this becomes 2. Of course, when you square root the centimeters, this square root sign will die with that, will remain with 2 centimeters. Is going to be equivalent to, now this is 576. What is the square root of that 576? Becomes 24. So it becomes 24, and of course that square dies with that, and then we remain with kilometers. So in other words, here we have that 2 centimeters are equivalent to 2 centimeters on the map are equivalent to 24 kilometers on the ground. But remember, we want a representative fraction. So one thing that we need to ensure is that these units are the same here. So it means that to make the two the same, because eventually these units are supposed to cancel out, we just want a ratio, so we need the units to be the same. So let us convert these 24 kilometers to centimeters. We can do that as some side work here and simply say that, 1 kilometer has how many centimeters? Well, we have King Henry's daughter Mary does careless mistakes. The kilometers are right here and the centimeters are here. So meaning that it's 1, 0, 0, 0, 0, 0. So meaning that 1 kilometer is going to have 100,000 centimeters. Therefore, the 24 kilometers that we are having here are going to be equivalent to, of course, x, meaning the value of x here is going to become 24,000,000. So it's going to be that, and this is in centimeters. So in other words, here it's going to become 2 centimeters is now equivalent to the 24 kilometers which we have converted, and they've turned out to be 2,400,000 centimeters. So you realize that these centimeters cancel out, these centimeters and those centimeters will cancel out. So this becomes 2 to that 2 to 2,400,000. Of course, this representative fraction is this ratio can be simplified further by 2 once. When we divide this by 2, we shall end up with 1,200,000. So it means the representative fraction now is 1 to 1,200,000. So now this representative fraction simply means that 1 unit on the map represents 1,200,000 units on the actual ground. So these units can be either 1 centimeter or 1 inch or whatever. So that is what the representative fraction is. That's how we get it. So moving on to the next question. So we have another one here. The edges of Lacour and Nancha are in the ratio of 4 to 1. So we have Lacour and then we have Nancha. Now their edges, the question says, are in a ratio of 4 to 1. So this is 4, this is 1. That is the ratio of their edges. So now that is the ratio of their edges now. So 6 years later, okay, 6 years later, they are telling us that the ratio of their edges will be 5 to 2. So 6 years, the ratio of their edges will be 5 to 2. Right now it is 4 to 1, and then now it will be 5 to 2. Now they're asking us to find their present edges. So we're supposed to find their present edges. Now, if the ratio of their edges is 4 to 1 right now, it only means that they're supposed to be these edges, the ratio of 4 to 1, if we want to find their total age, or I mean where they got these ratios from. This, for example, if we are to get the age of Lacour, it would mean it is supposed to be 4 times a certain number. Even Nancha, if I'm to get Nancha's age, it is 1 times a certain number. Let me do a simple illustration here to try and put something across. Let's say somebody, maybe this is a boy and this is a girl, okay? The boy is 15 years old and the girl is 5 years old, okay? So if I wanted to find the ratio of the ages between the boy and the girl, I'll simply come and say boy to girl, or to boy over girl, their ratios would be, I would say it's 15 over 5. Divide that by 5 once, by 5, 3. So it would be 3 over 1, and so it would mean that the ratio of their ages would be 3 to 1. Now, do you realize that I got this 3 to 1 after dividing their actual ages? Yes. So it means if I wanted to move from here to get back to knowing their actual ages, it would mean these ratios of 3 to 1, I will have to multiply them by a certain number. In this case, if I multiply this by 5 and I multiply this by 5, I'll end up with 3 times 5, which is 15, to 1 times 5, which is 5. This takes us back to the actual ages of the boy and the girl. So with this thing that I've done here, that is what I mean here. When I say that Lacour and Nancha, their ratios, the ratio of their ages is 4 to 1. So it means if I wanted to find their actual age, it means I'm supposed to multiply that by a certain number to get back to their actual ages. Now that certain number, we do not know it, so we have called it x. So I think I have explained that. So meaning that their actual age right now, let me wrap this away. So meaning their actual age right now is 4x, that is right now. However, here is after 6 years. After 6 years, the ratio of their ages is going to change to 5 to 2. So let me say here, this is Lacour and this is Nancha. Right now, their age, this one Lacour is 4x. And Nancha, theirs is x, right? 1x, which is x. Those are their ages. So after 6 years, so meaning I'm going to add here plus 6 years, even here plus 6 years. So after 6 years, their ratio, the ratio of their ages will change into 5 to 2. So what will happen here, or what we shall do, is I will simply come here and say, so well, their age after 6 years, so meaning this is after 6 years, this is how it's going to turn out. It's going to be 4x plus 6, divide that by x plus 6 is going to be equal to the ratio after 6 years, which is 5 over 2. So what we're going to do here is we're going to cross multiply so that we find the value of x, and that will help us answer the question. So this is going to become 2 whole numbers into 4x plus 6 is giving us 5 whole numbers into x plus 6. So now let's get to it. This is 8x plus 12 is giving us 5x plus 30. So collecting like terms, this is 8x minus 5x is giving us 30 minus 12. And definitely this is going to end up being 3x being equal to 30 minus 12, which is 18. When I divide both sides by 3 here, I will end up with my value of x as 6. Now that I know that my value of x is 6, let's get back. The question says find their present ages. So meaning their present ages, since we know the value of x, so it means their present age for Lacour will be 4x, which is 4 times 6, which is 24 years old. Then for Nancha, her age is 6. And that's the answer. So we have answered part A. So let's do part B of number 11. Part B, we're talking about Ouma here, takes 20 days. So we have Ouma, and it says that Ouma takes 20 days to plow a garden. Mukasa takes 30 days. Mukasa takes 30 days to plow the same garden. How long will it take the two men to plow the garden if they worked together? So we have Ouma, we have Mukasa, and they take some time. You know, Ouma takes 20 days to plow a garden. Mukasa takes 30 days to plow the same garden. So if they combine their efforts, how long will they take to plow the same garden? So we shall look for how much work each is able to do for that one garden. We shall denote the garden by just number 1. We shall say how much Or how much does Ouma plow in one day? Remember here he takes 20 days, right? So he takes 20 days to plow the garden. This guy takes 30 days to plow the garden. So how much does Ouma plow in one day? So let's say the garden, they are talking about the same garden. So let's say the garden is represented by 1. If that is how much, that is the garden, how much the garden takes. So it means for us to get how much Ouma does in one day will mean uh, the garden or the size of the garden, divide that by the number of days Ouma takes, which is 20 days, so that we're able to know how much Ouma does in one day. So we shall ask ourselves the same question: how much does Mukasa do in one day? Same story. So how much does in one day is going to be 1. That is how the work of the garden. Divide that by, it's one garden. Divide that by the 30 days Mukasa takes. So 1 out of 30 days, so that we're able to get how much the guy does in one day. So to get how much they both do, we shall come here and say how much they work if they combined efforts. So this means it's going to become how much do they work? It's going to become 1 over 20. Add, that is how much Ouma works in one day, plus 1 the garden, divide that by 30. That's how much Mukasa works. When you add the two, let's find LCM here. LCM is 60. 60 divided by 20 is 3. That is 3 plus, that is plus 2. So from here we shall end up with 5 over 60, which shall be by 5 ones by 5, 12. So it's 1 over 12. So this 1 over 12 simply means that when those two work together in one garden, when the two combine, when they work together, one garden, they will take how many days? 12 days. So to answer this question, we shall simply come back here and say that if they're asking us that, how long will it take the two men to plow the same garden if they work together, we shall say they'll take 12 days. That's the answer. So moving on, the pie chart represents yields of beans from 3 fields A, B, and C. If the total yield of the beans was 300 sacks, calculate the number of sacks got from field C. So here they're telling us that the total yield of beans was 300 sacks. Calculate the number of sacks got from field C. So if the total yield of beans was 300 sacks, it means that if we add this to that, it's going to give us 300 sacks of beans. These are angles. This is 120 degrees. This is 150 degrees, just much as the degree sign was not put. So this is angle C. So to get angle C, we shall say it is 360 degrees minus, the other two angles combined, 120 plus 150. So it's going to be 360 degrees minus, we are trying to find the missing angle of C. So this is 270. So 360 minus 270 is 90 degrees. So it means C represents 90 degrees. That is what it represents. So now they're asking us that to find the yields gotten from C. So that is simple. If the total yield of beans was 300 sacks, calculate the number of sacks got from field C. So the number of sacks got from field C is simply going to be 90. Divide that by the total angle sum, which is 360 degrees, times the total number of sacks, which is 300. And we'll be able to get our answer like that. That goes with that by 3 by 3 1 2, and we shall end up with 3 times 300, which is 900, divided by 12, and we shall end up with 75 sacks. Moving on, the farm is on a piece of land whose area is 5.6 kilometers squared. What would be the area of this farm in centimeters squared on a map whose scale is 1 to 40,000? So 1 to 40,000 is what we call the representative fraction. We did something like this in an earlier number in this session, so we have an idea what that means. So they want us to find the area of this farm in centimeters squared on a map whose representative fraction is this. Now, when we say that a representative fraction is 1 to 40,000, this simply means that 1 centimeter on the map represents 40,000 centimeters on the ground. It's the same way, or maybe you can say it's 1 inch on the map represents 40,000 inches on the ground. That is what it means. So this is what the farm has an area of 5.6 kilometers squared. So this is the area, the actual area. So they want us to find what this actual area would be on the map. Now you realize that this representative fraction here is linear. Okay. Since we are doing centimeters, it can mean that 1 centimeter on the map represents 40,000 centimeters on the ground. This is linear. But now we are dealing with area, and area is in centimeters squared. So what we do, let us get a representative fraction that is in square centimeters. So what happens is that we are going to square that, and we are also going to square that. So that now this is 1 squared, which is 1 centimeter squared, which is centimeters squared, is equivalent to, 40,000 squared. 40,000 squared is going to give us 16. So 1 centimeter, so now this means that 1 centimeter squared on the map represents 16,000 or 1.6 billion centimeters squared on the actual ground. So now the area whose actual ground we want to actually ascertain is this. So what we are going to find is we need to first convert this. We convert that to centimeters squared. When we convert it to centimeters squared, then it is from this that we shall be able to quote how much of this is represented on the map. And we shall be using this representative fraction that has been converted into centimeters squared as our guide. So from our representative scale, or from our scale of 1 to 40,000, we have been able to square both sides, and we have known that, okay, as far as area is concerned, because this is linear, right? So as far as area is concerned, 1 centimeter squared represents 1.6 billion centimeters squared on the ground. Now, there is an area we are interested in, which is 5.6 kilometers squared. Now, let's first look at that 5.6 kilometers squared. Let us convert it to centimeters squared. So that's what we are going to work on. We are going to convert 5.6 kilometers squared to centimeters squared. So let's begin with our conversion here. This is King Henry's daughter Mary does careless mistakes. So I want to convert from kilometers to centimeters. It's right there. So this means it's 1, 0, 0, 0, 0, 0, which is 100,000. So I will come and say that 1 kilometer represents or is equivalent to 10,000. No, it's actually 100,000 centimeters, like that. However, remember I am converting from kilometers squared to centimeters squared. So because there is the element of squared, it means I am going to square both sides. So when I square both sides, this is going to become now 1 squared is 1 kilometer squared is equivalent to 1. This is going to become 1 billion. And this is in centimeters squared. Now that I know that 1 kilometer squared is equivalent to 10 billion centimeters squared, what about 5.6 kilometers squared? Remember, I'm trying to convert 5.6 kilometers squared to centimeters squared. So if 1 kilometer squared is equivalent to that, therefore 5.6, what about 5.6 kilometers squared? So meaning 5.6 kilometers squared will be equivalent to this. Let's call it x. We are converting things to centimeters squared. So when we cross multiply, we are going to end up with our value of x being x times 1, which is x, is going to give us 5, 5.6, multiply that by 10 billion. And this is centimeters squared. Okay, so of course when we cancel out one of those zeros and that decimal point moves, it will come to 56 and the rest are the zeros. And this is in centimeters squared. So do you take note that now the thing we want, we have now converted 5.6 kilometers to centimeters squared. But now the question wants us to find these 5.6 kilometers, which we have already converted into centimeters squared. We want to see what area it's going to cover on the map in centimeters squared. So we come back here and we shall come and say, let me put this again. So we can come and say 1 centimeter squared on the map represents 1 billion 600 those kinds of 1.6 billion centimeters squared on the actual ground. Now, what about this 5.6 that we have converted into centimeters? This one. We now put it there. Therefore, 56 billion centimeters squared the 56 billion centimeters squared will be equivalent to, we put here x, because we are now converting what is on the ground to how much it's going to be represented on the map. Then from there, we shall go ahead and cross multiply. When we cross multiply, we shall end up having, 1.6 billion times x being equal to 56 billion. So I shall divide both sides by 1.6 billion. Divide both sides by 1.6 billion. Then we shall go ahead and cancel the 3 zeros like that. This 0 goes with that 0, that 0 goes with that 0. Of course, this will cancel with that. You remain with your value of x as 560, divide that by 16. So we shall end up with our value of x as 35. And that 35, this is 35 centimeters squared. So it means that 35 centimeters squared is the representative. In other words, if you come up here and see 35 centimeters squared, that is how much is going to be represented on the map. So 35 centimeters squared is what is going to represent 5.6 kilometers on the actual ground. That is what that is. So that's the answer. Moving on to the second last. A butcher sells 5 kilograms of meat at 10,000. If the cost of meat is increased by 20%, find the weight of meat which can be bought at 3,600. Okay, so we have a butcher sells 5 kilograms of meat at 10,000. So 5 kilograms, those ones can be sold at 10,000. Now they're asking if the cost of meat is increased by 20%. So if we increase it by 20%, it means that the 5 kilograms of meat are going to cost more. So let's first increase this 10,000 by 20%. So it's going to be, increasing 10,000 by 20% is going to be 10,000 plus the increment. The increment is 20% of the original price. So it is 20 over 100, multiply that by 10,000. So of course this is going to be 10,000 plus this goes with that, this goes with that. We remain with 2,000. So this is going to be 12,000. So it means now, because of that increment, that 20% increment, now 5 kilograms of meat, they are no longer 10,000. Now they are at 12,000 because of that increment. That's what the question says, that the butcher sells 5 kilograms of meat at 10,000 if the cost of meat is increased by 20%. So find the weight of meat which can be bought at 3,600. So in other words, here we know that 5 kilograms now, because of the increment, are to be bought at 12,000. So what about 3,600? As the question says, how much weight of meat can be bought by that? We call that x, then we cross multiply to find the answer. So upon cross multiplication, we shall end up with 12,000 x, giving us 3,600. Multiply that by 5. Divide both sides by 12,000. Divide both sides by 12,000. This will go with that. We shall end up with x being equal to this, go with that, by 5 once, by 5, it's 24. So we have 36 over 24, which is going to be equal to 1.5. So we can have 1.5 kilograms to be bought. That is how much meat you can buy with this 3,600. And that's the answer to that question. So doing the very last one, given that V is inversely proportional to T squared and V is 25 when T is 2, find V when T is 5. So the question says, given that V is inversely proportional to T squared, that's the representation. V is inversely proportional to T squared, and V is 25 when T is equal to 2. So they want us to find the value of V when T is 5. So how do we go about this? We are going to have to first find the equation that relates V to T, and it means that we are supposed to eliminate this proportionality sign by introducing an equal sign. So it means that it's going to become V is going to be equal to 1 over T squared. But when we introduce that equal signs, we introduce a constant of proportionality. I'll call it K. It can be any other letter. So in other words, this is like saying V is equal to K over T squared. So we find that value of K first. So V, when we know that when V is 25, T is 2. So V being 25 means this is 25 is going to be equal to K times 1 over T squared, which is 2 squared. So from there, what we can see, this is going to end up being 25 is going to be equal to, K over 4. Multiply both sides by 4. So that this goes with that. We shall end up with K giving us 100. So if K is 100, it means that now what we have, then our equation is V is going to be equal to 100 over t squared. Now, if v is equal to 100 over t squared, now we can now go ahead and find v when t is 5. So we can go ahead and say, therefore, v is going to be equal to 100, divide that by t squared, which is 5 squared. So that means it's going to become 100, divide that by 5 squared, which is 25, and so we shall end up with our answer being 4. So our value of v is 4. So that brings us to the end of the examination style questions. If you feel there is any topic or any number that you feel I should delve more into, just simply let me know in the comment section, and I will try my best to, explain it in another video and explaining it in a way that brings out the concepts from very first principles. These are examination style kinds of questions, so that means that I am explaining them with the mind that you have covered most of these topics in class from scratch, and that your teacher has been able to explain these things, introduce the topic to you and explain things to you in their entirety. So I am not going so much in depth, I'm just explaining how things are done. However, if you feel there is a number that I've done here of a certain topic and you feel I should do a series on the topic in depth, just let me know in the comment section below and I will work around the clock to see what I can do. Like this video if you like it. Don't forget to subscribe. Check out other math videos on the channel. My name is Arnold Rangakuramia and this is Kisembo Academy. Take care.